All right. Good morning, everyone. Yeah, sorry about the very late start. We had some technical issues with Mike, but our IT seems to have sorted it out. Welcome to everyone in-house and all those who are logged in online. Can someone online please just confirm that that you can hear me clearly? Alden, just check to see if just check to see if anyone is saying that they can hear me.
Confirmed.
Okay, thank you very much. All right. Okay, thank you. So, good morning, everyone. Again, this is our second presentation on improved construction practices. Some of you, I know one or two faces from the last one. We had it in 2020, and that one was focused on homes. This workshop, we have tried to expand a bit more on certain areas of construction. So instead of taking apart a building and doing each element, what we have done is focused on certain materials and certain specific elements of the building. Okay. So our first presenter this morning will be Mr. Linus Gustav. He will be presenting virtually. So I will go ahead and pass over to Mr. Gustav. Linus, are you there? Can you confirm audio?
Confirm, I'm there, Jamal. Good morning.
All right, so go ahead and start that presentation. Persons online, someone just confirm if everyone can see the shared screen.
The screen has not been shared. Yep, screen is now shared.
Okay, so Mr. Gustav, we will switch to the slide. You will indicate when you want us to switch to the next slide. Okay.
Okay, I will. Thank you, and good morning to all in attendance. My name is Linus Gustav, and I will be presenting the concrete segment of the workshop organized by the Institute of Architects of St. Lucia. Before I delve into the topic at hand, it is worth noting the importance of safety, especially when working with fresh concrete. Care should be taken to avoid skin irritation or chemical burns. Prolonged contact between fresh concrete and skin surfaces, eyes, and clothing may result in burns that are quite severe. In this case, seek medical attention. Proper safety clothing must be worn when working with concrete. Concrete is one of the most widely used building materials because of its durability and availability. It can be used in almost every element of a building, from foundations and walls to roofs, counters, and balusters. However, if concrete isn't properly mixed or laid, it can easily fail, and repair or replacement is usually very costly and time-consuming. In this presentation, I will address formwork, mixing and sampling, placement, pouring, and curing. You can now turn to the next. Concrete formwork. Formwork is a mold which is used in construction for giving concrete elements desired shape and size. There are many different types of formwork available in the market. Timber, plywood formwork, steel formwork, aluminum formwork, to name a few. Timber, plywood formwork. Timber formwork has the lowest initial cost, but has the lowest possibility for reuse. After a second or third use, timber or plywood will tend to be too worn to provide smooth and flat reuse. From oil or other foam release agents should be used to ensure ease of removal of formwork and to extend the life of your timber forms. This works by preventing concrete from adhering to your formwork. It can be painted, rolled, or sprayed onto formwork before steel is placed. A few illustrations are present there. Framing. Your framing is possibly the most important part of your formwork. Size of members and spacing depends heavily on the total weight it will have to support. Be sure to consider the weight of concrete. Concrete weighs 50 pounds per cubic feet. The weight of the reinforcement, the number of workers, any equipment being used, and pouring methods. When planning your framing, ensure that you have horizontal members under every joint in your decking. This will help prevent failure and warping. A few illustrations are present there. Flaws. The result of poor framing or bracing can range from mild cost increase, including increased concrete volume, to catastrophic failure, which result in loss of life. Metal formwork. Steel formwork consists of panels fabricated out of thin skin plates. Steel formwork is popular because it gives a long lifespan, and although it has the highest upfront cost, it also has the highest reuse rate. The steel panel units are fixed together using suitable clamps, nuts, and bolts. Steel panels can be fabricated in any modular shape or size. Aluminum formwork is similar to steel formwork, but is lighter, thus making it easier to handle on site. This type of formwork is economical because it has a high reuse value, but tends to be dented and damaged more easily than steel if handled improper. Mixing and sampling. Some basic mixing ratios for concrete are the 1:3, the 1:3:3, the 1:4. These mixing ratios are based on the proportions of cement, sandstone in that order. The ratio you use will depend on what PSI strength you need. Water, clean, cool water is best. And we have two mixing charts. You can always pick the strength from. The strength of concrete will depend on how much water you use to mix it all together. Basically, this means the more water you use to mix the concrete, very fluid, the weaker the concrete mix. The less water you use to mix the concrete, somewhat dry, but workable, the stronger the concrete mix. Accurate concrete mixing ratios can be achieved by measuring the dry material used, using buckets or even a shovel. Note, once the desired mix ratio is used, extra water should never be added to the mix in order to achieve workability. Various admixtures are available for increasing the workability of drier mixes of concrete. Concrete ordered from a batching plant has already been mixed to its optimal ratio, and only admixtures should be added on site. On-site mixing methods. Proper and sufficient mixing of the materials is essential for the production of uniform concrete. The mixing process ensures that concrete becomes homogeneous, uniform in color, and consistent. Hand mixing, as the photo illustrates, is practiced for small-scale, unimportant concrete works. In this method, as material mixing is not sufficient compared to machine mix, it is desirable to add 10% more cement to cater to the inferior concrete produced by this method. Machine mixing of concrete for large constructions. The concrete mixing is done by machines only. Mixing of concrete in a mixer is not efficient, but also economically when the quantity of concrete is to be produced is large. These plants are either site-mixed or stationary. The drum type of mixers may also be used on site. This type of mixer is mainly suitable for stiff and lean mixes, which present difficulties when most other types of mixers, mainly due to the sticking of mortar in the drums. Note, concrete mixing time is as important as the ratio. The mixer is generally desired to run at speeds of 15 to 20 revolutions per minute. For well-mixed concrete, it is seen that about 25 to 30 revolutions are required in a well-designed mixer. On a construction site, the normal tendency is to speed up the outturn of concrete by reducing the mixing time. This results in the poor quality of concrete. Sampling testing, the two main forms of sampling concrete on site are slum tests, determines the workability of the concrete, and is usually the desired specifications. Cube samples, these are concrete samples which should be taken at random intervals from various batches of concrete. Please note, both of these should be performed by a trained technician. Placement and pouring of concrete. Before any concrete is poured, a plan, a program should be developed, taking the following into account. All concrete conveying equipment should be in place. All formwork, bracing, reinforcement, etc. should be clean, suitable, and in the correct positioning. Concrete should be placed in its final position and compacted before cement reaches its initial set within 30 minutes of leaving the mixer, and should not be disturbed or rehandled thereafter. Concrete placed in restricted forms by barrows, buggies, carts, cubes, or hand shoveling should be subjected to the requirement for vertical delivery of limited height to avoid segregation. Concreting, once started, should be continuous until the pour is completed and should be in place and should be placed in successive horizontal layers of uniform thickness up to 900 millimeters as seen in the photo. Vibrating, except for self-compacting concrete, all other types of concrete are normally vibrated by suitable means for consolidation. The following are key reasons for vibrating concrete: to reduce the air contained in concrete, generally 5 to 8%, which reduces concrete density; to avoid segregation; to avoid bleeding; to improve the bond between cement and reinforcement. Vibrating methods include surface vibration. This method is suitable for depths between 150 to 250 millimeters. Poker vibrator. This is the most widely used method of vibration for concrete depths between 150 and 250 millimeters. Formwork mounted. This method is usually used in steel formwork as it tends to put a strain on formwork joints. Platform vibrators. This is used mainly for prefabricated elements which are cast on a metal surface. We have the different forms, types of vibrators available on the market. Proper vibration technique is key. Under vibration, concrete will be weaker and tend to have honeycombs. Over vibrated concrete will also be weaker since it will cause material segregation. Formwork can also be put under excess strain by the vibrations, and we have the two examples below.
One second, Elinas, give us a chance so we can play those videos for them.
Yeah.
In the construction industry, concrete quality management issues are common. Since we are working with this material, it is often not understood correctly. One of the problems that occur when not vibrating the concrete properly is better known as honeycombing. Honeycombing is when there are coarse areas with an insufficient amount of fines that are seen as open cavities left in the concrete. Deep honeycombing will result in less covering around the steel reinforcement. That will affect the structure's durability. Today we'll be looking at how to guarantee that honeycombing does not occur by ensuring proper concrete consolidation. This is the internal vibrator. The vibrator has a rod on the inside which causes the outer shaft to vibrate. Different head sizes of the vibrator are used depending on what type of section needs to be vibrated. Before we start looking at the consolidation process, it is important to note that safety gloves should be worn at all times when using the internal vibrator. Let's start looking at the vibrating process. It is important that newly placed concrete immediately gets vibrated. When working with the mix, it is very important that the mix is not too stiff or too wet. When lowering the internal vibrator into the concrete, it is important that it is never forced down, but allowed to move down due to its own weight. The internal vibrator is left inside a certain position for 5 to 15 seconds, depending on how long it takes for all air bubbles to stop moving towards the surface. The internal vibrator is then slowly removed from the spot at a rate of 100 millimeters per second, before it is replaced 500 millimeters from the original spot. Proper consolidation will have occurred if a thin film of mortar is presented at the top of the surface, and if all air bubbles have stopped rising towards the surface. During the consolidation process, two common errors often occur. Under consolidation is when an area has not been properly vibrated and aggregates are visible at the surface. Over-consolidation is when an area has been vibrated for too long, causing all aggregates to move towards the bottom and only fines are visible at the surface. In conclusion, during the consolidation process, the following three aspects should always be remembered. That you should never force the vibrator down the concrete, that the vibrator should be left in one spot for 5 to 15 seconds, and that the vibrator should be left in one spot until all the air bubbles have stopped rising towards the surface.
Okay, Linus, back to you.
Curing. Curing is the process of maintaining the moisture of freshly placed concrete to complete the hydration process and to ensure proper hardening, attaining desirable strength and durability. 7 to 10 days of curing is recommended. This is highly dependent on weather conditions. Benefits of curing: the resistance of concrete to abrasion is considerably raised by proper curing. The curing protects the concrete surfaces from sand and wind. The presence of water is essential to cause the chemical action that accompanies the setting of concrete. Concrete strength moderately increases with age. If curing is efficient, the durability and impermeability of concrete are increased and shrinkage is decreased. Curing methods: the most common methods of curing are as follows: water curing, membrane curing, application of heat, steam curing, application of curing compounds. Water curing is the best method of curing. In this method, water is applied to the concrete surface for a certain duration. There are the following ways of water curing: ponding, spraying, wet covering. Wet covering slabs, roofs, etc. are covered underwater by developing water ponds on the concrete surfaces. Vertical walls, columns, plastered surfaces are cured by the sprinkling of water on them. Horizontal surfaces are kept wet by covering concrete with wet sand, sawdust, etc. Membrane curing: in some places where there is an acute shortage of water, membrane curing is adopted. Generally, water mixed by making concrete is more than sufficient to hydrate the cement. Membranes are applied all around the cement or around the concrete, which will effectively seal off the concrete. The membranes seal over the concrete by means of a firm impervious film to prevent moisture in concrete form, especially by evaporation. This prevention of moisture in the concrete will work as curing of concrete. Heat steam curing: application of heat steam curing when concrete is subjected to a high temperature with an excess of moisture if accelerates the hydration process and results in higher development of strength. The concrete can be subjected to dry heat because of moisture, which is also an essential requirement. Thus, for achieving this goal, concrete is required to subject the steam curing. The steam curing will not provide only economic advantages, but also technical advantages to the concrete in general. It is employed in the prefabricated concrete component. Curing compound, there are certain compounds that keep the concrete wet. Calcium chloride is one such curing compound. It can be used as a surface coating. Calcium chloride is a salt. It shows an affinity of moisture. The salt not only absorbs the moisture from the atmosphere, but also retains it at the surface. Salt keeps the concrete wet for a long time to provide hydration, to promote hydration. The curing compounds are available on various bases, like chlorinated rubbers, sodium sulficates, wax, licensed oils, bitumen, auxiliaries, and other items. Please note, the following are important to note when dealing with fresh concrete. Do not paint or stain concrete in the first month. Do not subject new concrete to excessive weight. Concrete which is not kept hydrated will develop shrinkage cracks. When planning a pour, it is best to begin early or wait until later in the afternoon when the heat index has fallen considerably. Hot, dry conditions will accelerate concrete dehydration and reduce your workability time. When waiting for concrete to dry, keep these time frames in mind: 28 to 48 hours after initial set. Forms can be removed and people can walk on the surface. 7 days after practical curing, traffic from vehicles and equipment is okay. 28 days at this point, the concrete should be fully cured. Concrete admixtures can make your life a lot easier by adjusting the behavior of concrete. Instead of adjusting your concrete mix proportions, try using admixtures to do the following: accelerate to increase the rate of strength development at early ages. Calcium chloride is the most widely used accelerator. Retardants to slow the initial setting time while pumping concrete over a long distance or where extra work time is necessary. Water reducer to increase the workability without changing the water context. Pyrolysis such as fly ash is used. And I thank you so very much. And with this, I'll hand it over to Mr. Jamal. Thank you, sir.
All right, thank you, Linus. I'm not sure. I know we started very late, so we won't spend too much time. If anyone has any questions, please be sure to go ahead and ask them. Anyone online as well, you can feel free to post your questions in the chat group, in the chat of the meeting, or you can raise your hand and we will allow you to pose your question. From that last presentation, I really wanted to point out that the vibration is something that we don't see very often down here on a lot of construction sites. And that's why it was important for us to raise that point here. You'll find that most construction sites you go on, there isn't even a vibrator present on site. Vibration is key in concrete. As I say, unless you have an additive in there or the concrete mix is such that it is self-leveling, you need to have a vibrator on site. There's no two ways about it. And there's more than one. You can get some small ones that are connected to a power outlet, or you can get others that are connected to a compressor, but those are the larger ones for deeper pours, etc. So as I said, keep in mind vibration and curing. I think those are two things that we don't pay enough attention to down here. All right.
If I can share also, Jamal, we tend to pour concrete when the temperature is at its peak. I never understand why we keep pouring concrete at 2 in the afternoon. We constantly want to pour concrete in the hot temperatures, as opposed to early or very late at night. That always baffles me. But we see the results when we do that. We see early cracking, we see failure, and we wonder why we have a poor quality of a mix. Just to share a few.
I wanted to this is Francis. I'm actually online. I don't know if you guys can hear me, but
yes, we can hear you clearly.
Yeah, one of the things I think that, the architects and the engineers association could probably come up with some sort of specification that would help, especially if you're doing public construction. And, like in North America, they would put a vibrating portion and curing portion in the specification, especially for like I say, public construction, government construction, so that the contractor would, he would buy the plans and the spec, meaning that he would have to adhere to the spec and use what's in the spec, especially when it comes to vibrating. I see it a lot when I come to St. Lucia, and the curing, that's another issue by itself. So, I want to just say, kudos to Mr. Linus Gustav. Very, very, very good presentation there.
Very good point. I would say, though, that on larger projects in St. Lucia, especially larger government projects, the specifications usually insist on curing methods and vibration. I've been on quite a few of the larger projects. The issue is that on a lot of the smaller projects, you don't find any of it happening. What I would like to organize actually is some vibration training, because even when persons have a vibrator on site, you find that most people don't know how to use it properly. So they either over vibrate or they under vibrate. That is something that I suspect we will try to organize between us and the Engineers Association, and possibly with one or two of the contractors. We can organize and maybe even get some persons trained in proper vibration methods, and maybe taking of slumps and cubes as well, because these are all things that should be done on site.
If I can add, Jamal,
sure.
It points to building standards. I think this is where we need to take it to building standards. If the contractors, especially you see it on government procurement projects, there's absolutely the concept of vibrating and proper curing. It's just absent. Like you can always say nobody cares about vibrating, as if the consolidation of concrete is not key to a proper end product. And it is the key. To consolidate concrete, you must vibrate concrete. When a batch is poured, you have thousands of air pockets from that concrete. And if you look at a proper vibrated concrete, once you pull the poker out, it's supposed to seal the hole immediately. If you still see the bubbles, it means there are a lot of air pockets and you're going to get honeycomb. So you look at I passed on a number of projects and I can just look and say, well, yeah, nobody cared about, especially in the beams. Especially if you put in the front there deep beams, you must vibrate these beams to get proper compaction.
Yeah. And what you find a lot of the time is the guys will tell you they'll just hit the formwork with a hammer, just to smooth it out at the edges a little, so you don't see the honeycombing. But that doesn't ensure that you have proper consolidation inside of the beam and the slab. Okay, so unless there are any further questions, we'll move on to our next presenter.
Hi, sorry. Good morning.
Oh, yes. Go ahead.
Yes, this is Marie-Therese Louis. I just wanted to raise the previous person, I think it was Mr. Francis mentioned about specifications. I would like to second that. I note that we're speaking more of a smaller project base. However, there could be a case for standard specifications that could be made available to persons, like for technicians to be able to use and to assist with monitoring of works that are happening on the smaller scale. I think a lot of private sector organizations who are funding these projects would be in agreement that we need to have something that is not as large scale as what we see on government projects, but as something that can be used. There are things online that either this association or the engineers one could come up with that we can say this is the base that you start off, this is the minimum that you should have, right? I think the materials that were touched on in the presentation, I think that in terms of cementitious material, there are a lot of different cement types available on the market. Knowing which one you're getting is important. I think that saying to persons, you go and buy cement, you should at least know what you're getting, because there's general use, there's type 2, type IL, type E, type IS, and so on. So I think what we have on the market should be something that laypersons should be able to know, okay, this is what I'm getting. Because with regard to high early strength, there are some times that you can get a high early strength cement and people get it and they're not sure what they've got because they don't know that there are different types. The last thing I would like to point out is that for submittals, this is probably for the large scale projects, I think we need to push as, the design professionals that in the specifications, we identify what documents need to be submitted. Quality starts from good submittals, knowing that the person executing the job is aware of the quality requirements for the project. And the second thing is for design professionals to ensure that these documents, when they are stated as submittals, they enforce it and require that the contractor or the contracting personnel submit it for review. I think that's something that we're not seeing enough of, because of even on the larger private sector projects, some of the contractors who have had much experience in the profession are not aware of the requirement for submittals, and that it is their responsibility to communicate to the person doing the monitoring of the project, ensuring the quality requirements, that the contractor is aware of what is required. So these are the three things that I think: standard specifications, submittals, enforcement, and making sure that in this forum that you've mentioned, Jamal, that where we're talking about training, more hands-on training, that persons see the type of materials that they will be using and should be using on their projects.
Yeah, very, very good points. Thank you very much for that.
Okay.
And maybe I'll give you a call when we're planning that so you can be involved. How's about that? Right,
sure, I'm happy to assist. Okay.
All right, great, thank you. Unless there are any other questions, I can say let's move on to the next presentation. You have the slide ready?